What's up? It's Mr. Wicklehouse. Today, we're talking about function notation and operations with functions. Let's get busy with it. So as we are going through math and getting higher up in our math classes, we'll find that this variable y that we're so used to seeing, like a y equals mx plus b, etc., it's going to start to disappear. In its place, we're going to use, in a majority of situations, the symbol f of x. Okay? F of x means function of x. Okay, so this is function notation. To be a function, when we graph these things, they need to pass the vertical line test. Okay? What the vertical line test is if you have a graph like this, and you have some kind of equation that you go through and graph, it looks something like this. If you take a vertical line, a straight up and down line, and you move it across your function, like so, then you'll see that it only crosses one time. So as we're moving across, if I do a vertical line up and down, then this guy is only going to pass through in one point. Okay? As a counterexample to that, not a counterexample, but as a different example to show that something is not a function, let's look at this circle. Okay. Well, if I do a vertical line on this, here's a vertical line right here, then we see that this passes through more than once. So this equation, or this guy right here, is not a function. This one is a function because it passes through once. This is not a function because it passes through twice. This should all be reviewed for you guys. You should have seen all this stuff in Algebra 1. Just a refresher here on that. So all of our linear equations that we've been talking about, and absolute value equations and all that stuff in the first few days, they can all be written as f of x equals 2x plus 3 instead of y equals 2x plus 3. That f of x is just taking the place of the y. Okay, so that's our function notation. Moving on. We can add functions. So if I have two functions here like this, f of x equals 2x plus 1 and g of x equals 4x plus 2, then somebody might say, what is f plus g of x? Okay, so all I do here is I'll take f of x and add this other function called g of x. So I'm going to take this 2x plus 1 where the f of x is, so 2x plus 1, and put it in its place. Take the 4x plus 2 and put it in the place of g of x, so 4x plus 2. I'm going to combine terms now, so 2x plus 4x is 6x, and 1 plus 2 is 3. So f plus g of x equals 6x plus 3. Easy peasy. We can also subtract functions. Okay, this is the same idea. So if I've got 2x plus 1 and 4x minus 2, taking f of x minus g of x, these mean the same thing. And I take 2x plus 1 and I subtract, and this is the important part. Make sure that you put this in parentheses so you don't forget that we're subtracting both parts. Okay, but I'm just plugging 4x plus 2 in for g of x. let's distribute the negative. So I got 2x plus 1 minus 4x minus 2. Now I can combine things. 2x minus 4x is minus 2x. 1 minus 2 is minus 1. Okay. I've already hinted at this up here, but this notation and this notation mean the same thing. So f plus g of x, and this is f of x plus g of x. They're the same exact thing, and I'm going to do the same exact thing with these. So where the f of x is negative x minus 3 plus 2x plus 5. Combined terms, negative x plus 2x, that's 1x. Negative 3 plus 5 is plus 2. This and this is the same exact thing. And you just plug things in for these. Okay? Same idea. Look at this one on your own. See if you can figure it out on your own. Alright. So not only can we add and subtract functions, we can also multiply functions. We can also divide functions, but we're not going to talk about that right now. That can get kind of complicated. So sometimes they might give you a list of a bunch of different functions. So here's 3 different functions. F of x equals x plus 1, g of x equals 2x minus 3, h of x equals negative x plus 2. And they'll give you a few little problems to solve. So f times g of x. So I'm taking this, and I'm saying this is the same as f of x times g of x. So I'm taking f of x and plugging that in, plus 1. I'll put that in parentheses, and then I'm going to multiply that by g of x. So remember, if I have something outside of the parentheses and there's nothing in between, that's going to be multiplication. So since I'm multiplying these, I'm essentially going to FOIL. So the first 2 here, so x times 2x is 2x squared. Outside, x times negative 3 is negative 3x. Inside, 1 times 2x is plus 2x. And then the last ones, 1 times negative 3 is negative 3. Combine like terms, I get 2x squared minus x minus 3. Okay? Just multiplying these 2 functions together. Now let's do f of x times h of x. Okay? Well, I'll do x plus 1 times h of x is negative x plus 2. X times negative x is negative x squared. X times 2 is 2x. 1 times negative x is negative x. 1 times 2 is plus 2. So I've got negative x squared. 2x minus x is plus x plus 2. And we're going to multiply those together. Alright. Now you might be looking at this one here and you might be saying, what in the world is going on, Ms. Woodhouse? What's this 4 mean inside of here? All this 4 means inside of here is if you go up here to h of x, you're going to take that 4 and you're going to plug it in for the x. So now we've got negative x with the 4, so negative 4 plus 2. And then we're multiplying that by g of negative 2. So I'm taking the negative 2 and plugging it in for the x here. We got 2 times negative 2 minus 3. Simplify things inside of here. Negative 4 plus 2. That's negative 2. This one is 2 times negative 2. So that's negative 4 minus 3. Couple more steps here. The negative 2 is going to stay where it is. Negative 4 minus 3 That's going to be -7. Then I multiply -2 times -7, and that's going to be a +14. So sometimes they'll give you some problems like this where they want you to plug these numbers into your functions and then do the operation. It's really the same. This could be used for addition, subtraction, or multiplication, or any function for that matter. Okay? That's really all I got. I'll talk to you guys later.